stop. Can't stop.
It's just message after message after message.
I hope it's all good news.
It's mostly just random work stuff. Um,
That's probably good advice. I've turned mine off as well.
yeah, the Planetary Science Institute is incorporating us more and more into their day-to-day activities.
Hmm, hmm.
So I'm in the Slack channel where we're figuring out IT issues, looking ahead to
Yeah.
what servers do we want to use for different things, and it's great. It just also means sometimes it doesn't stop.
I I know the feeling. I feel bad sometimes because I get just overwhelmed at the
Yeah.
amount of just stuff that I have to think about. I have to make decisions nonstop all the time,
Hmm.
right?
Hmm.
And sometimes I'll even kind of like lash out. I'm just like, what do you want to eat for dinner? I'm out. I can't think of
I
things. Just, you know,
Yes.
can't.
I am so with you on that one. I gave up caring about food years ago.
Yeah,
Although this summer my latex allergy became revenge of the latex allergy,
right. Yeah.
and the number of foods I can eat plummeted. So,
Oh, yeah, yeah. You sort of got to the bottom of this allergy,
yeah.
right? It turns
Yeah.
out everything that you like is also covered in latex for some weird reason.
It genetics, that whole everything branching, different things you don't know are related
Yeah,
somehow are producing the same proteins.
right,
Like somehow tomatoes contain the same protein as the natural rubber tree.
right. Which you are now allergic to.
Yes.
Yeah.
Yes. I am
Oh,
way overlit.
one, and I'm totally differently lit. So I've hooked up my DSLR as my web camera now.
Yeah.
So hold on, you can't see it, but this is what it looks like. So you can sort of see the difference between us.
Oh, you look like you are in the smoke that is outside of your
Yeah, I'm
house.
not. It's the I haven't messed with the white balance of my camera yet, so
Okay.
we're not there yet. But I still am. I like playing around with having that as a webcam, so I'm just going to be able to mess with the white balance, and I should be able to figure it out.
So,
Did you see the trailer for the new
Dune?
Dune movie?
Yes.
Yeah. Yes,
Yes, I
please.
have gone down so many rabbit holes, so many rabbit holes.
Yeah.
That was my favorite book growing up until I started reading Orson Scott Card books because I didn't know yet that,
Yeah.
like, yeah,
Yeah, it's funny. Logan's actually reading the second Speaker for the Dead right now,
yeah.
and I'm like, dude, just remember, and sort of told him the whole story of Orson Scott Card and sort of that. But yeah, yeah, it's unfortunate, but I guess it's sort of the whole J.K. Rowling question as well.
Yeah. Sometimes you find yourself in love with the art but not the artist.
Yeah,
So, my theory on that is only buy used art at that point. So,
I think it's possible to separate the art and the artist.
yes, I just that's where the whole like only buy used books comes in and stuff.
Oh, I
So,
get you. Right.
yeah.
Haha, you've hacked the system.
Yes.
Yeah.
I want to hack my lights though. Can you hold on a second while I switch which lights are in
Sure,
action?
I'm sure the audience is fine with that. I'm going to say hi to them. I forgot to do that during the
Okay.
weekly space hangout. So,
Oh
hello to
no.
Andy Cowley, Beth Johnson, Bill Smith, Cherry, Shay K, Chris Adams, Corey S, Daniel McCool, Dustin Haskins, Guido Bibra, Ian Farquhar, John Suffill, Justin Proctor, Jorn Albert, Caillou Wen, Kylie Cerna, Matt Shaw, Mrs. Net, Miss Scooper, Nancy Graziano, Paranor, Paul Gracie, Rich Wilson, Sir Goosey, Sick James, Steve Heistand, Tall Paul, Did You Want You To, and Zeph and Zeph. And hey, everybody, welcome to the first episode of the new season of Astronomy Cast. We already have lots of good shows already planned out. And so I hope you guys will all enjoy what the new season brings. It's going to
I'm not
be
sure I made this better or worse.
doesn't matter. It's just audio. It's a podcast.
It's true.
I still get people sort of shocked and surprised to see me and to know what I look like. I'm just like, You know, I listened to you for 10 years. I never knew. And then I saw a picture of you and I always thought you looked like, and then they say somebody else. They imagine you to be some small little high energy guy as opposed to, you know, what I actually am is.
I was confused when I first met you. I have to admit that.
Really? Okay. Yeah.
You look more like your voice now than you did originally with your weird curly hair. Your hair is great long. Your hair is great super short. The in between.
Yeah, not so good. Yeah. But yeah, anyway, so it's funny. It is always so funny how people, we have no control over how people interact with all of our content, right? And so all we can do is just be in all the places and hope that somebody enjoys some portion of it. Like I mentioned the podcast that we do in the newsletter, and people are like, "You do a podcast?" I'm like, "Come on, yes, I do a podcast."
Well, haven't you had people claim that you're plagiarizing yourself with? Yeah, that's my favorite.
Yeah, I have people claim.
We've started getting the same takedown notices with Daily Space that you get for using NASA content.
Have fun with that. Yeah. So hold your ground, because they are they're so wrong. And I'm like really a little snippy about it. So I'll say like, "Are you claiming to own the rights to video from NASA? Is that what you're saying? Is that the claim? Is that the legal claim that you're making?" And they always back down. And even if they don't back down, like I'll walk, because obviously they're in the wrong and they need to be punished. So, all right. What do we do?
I think I'm going to say hi to the people on Twitch now that I am not disgusted by my lights.
Okay.
And I forgot to start my audio software. So I'm going to start it opening while I say hello to Paranor Planetary Pan. More Planetary Pan.
Wait, Beth Johnson is in our feed as well.
She's all the places. She is all the places. Keeper of Maps. Serotonin Junkie. Nightbot. Nightbot is present all the places. That's it so far. Those are the only people who've talked to us over on Twitch.
All right. So let's do an astronomy cast.
All right. I am pressing record. It is asking for an episode number.
577.
Dang. We're going to hit 600 this year.
Neat.
All right.
An arbitrary number. Okay.
Not recording. Why is it not recording? Dear audio. One moment.
So for people who are wondering about the rest of the seasons, we've already started the Weekly Space Hangout. If you missed it, it was awesome. Talking to Dr. Katie Mack about the end of the universe. And I could tell she was super sick of having the same conversations. And so I just went in totally different directions. Talked about weird and obscure stuff that I wanted to talk about. And I think she enjoyed, it was a little different than all of the interviews that she's had so far, but it was a lot of fun. It was great to see people back.
She's been on everything lately. Mm-hmm. Like I fell asleep with NPR on and had weird dreams because she was on the radio, and then I woke up and she'd been in my dreams, and then she was on the radio, which is why she'd been in my dreams.
It's okay to have Katie Mack on the television, Katie Mack on the radio, Katie Mack on big billboards, but not in your dreams. Never in your dreams. That's not your microphone. No.
It is for my recording.
Well, that's fine.
It says it's my microphone.
Sure didn't make a sound when you tapped it. Whoa, that's weird. It did make a sound. It's got some kind of noise canceling or something?
Zoom does.
Huh.
Yeah.
Zoom. Okay. So, and then I've got the next open space is starting up on Monday. Some people liked the open QA with me. Some people like the guests. So I've decided just to do both. So we're going to have I'm going to have a QA every week and a special guest every week. And I'm thinking the special guest is probably going to be at random times that are convenient for the guest.
Yeah.
Because I have a lot of guests who are in Australia or guests who are in Europe, and it's really tough to do a set time. So I'd rather just, some people You're out of luck if it's nighttime while we have the guest, but that way people can see them. And then we were going to start the virtual star party on Saturday night, but because of the wildfires, we've pushed it back a week because just like none of the telescopes are going to operate.
Now, is Vancouver Island still doing okay?
We're fine. Yeah, we've had a very wet summer, so we haven't had. This is like the first season that we haven't been on fire. So.
Oh, the world we live in.
Yeah, exactly. All right, I'm ready to press record. Are you ready now to press record?
I've been recording for a minute.
Maybe you want to start
again. For a hot minute. Do you want me to restart?
Just so we're easier to synchronize.
Okay. Whoa.
For
I
Richard.
clicked in the wrong window and it complained. All right, I'm pressing record in 3, 2. It is recording.
I'm also recording.
Hi, Richard.
Hi, Richard. Welcome back. All right. Astronomy Cast, episode 577, Mars in Opposition. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Frasier Cain, publisher of Universe Today, and with me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, welcome back from summer hiatus. I missed you.
Thank you. I've missed you too. Although I have to say, it feels like we're like experiencing March 200 instead of September at this point.
Time has no meaning.
It doesn't.
Yeah.
It really has no meaning.
It's a snake in a circle eating its own tail, made of everything and nothing all at the same time.
Yeah.
I don't know whether I'm coming or going. The days just blur, and yet time just takes forever. When do I get my vaccination? You know what I want to do? Oh, I was thinking about this. You know what I really want to do? I want to go places and see people.
Yeah.
That's what I really want to do. I want
to have gone from having that amazing experience in January where we were together in Hawaii for the AAS meeting.
Yeah.
And towards the end of that meeting, we were starting to talk about the news about this strange illness in China. And I remember the Thursday night talking with a couple of my friends at the conference about, okay, I just want to get home before the illness makes it to Hawaii.
Yeah.
And I had no idea that 9 months later,
this would be our life.
Yeah.
Still. Yeah. No, yeah. I had my suspicions, but and now we do feel like we're closing in now on the final stretch, that more and more vaccines are coming into the final stage of trials, and there's going to be some kind of rollout, but I really hope that herd immunity will start to get kicked in and we can start to see the end of this. Hopefully during this season. So we will.
And herd immunity from vaccines.
Yes, exactly. Yeah, not from just everybody getting sick. So we
have
will
to be specific.
Yeah, so I'm hoping we will see the end of it during the season and regular life will return.
This is season 14. Our show is a teenager, and I feel that having a very cranky year is consistent with going through our teenageness as a podcast.
Thank you for reminding me what season this is. All right. Every 2 years or so, Mars lines up nicely with the Earth. It takes only 2 minutes to communicate with the rovers. You can see the polar ice caps in a small telescope, and it's the best time to send your spacecraft to the red planet. And also, I guess, Mars opposition, that's when your Mars horoscope is really good. Is that how that works?
I have no idea.
I don't know either. Maybe that's Mars in retrograde. Or is that an unlucky
They can
time?
happen at the same time.
Mars in retrograde and in opposition. Yeah, I guess they can. That's true. All right. So we're going to talk about how Mars in opposition is a really like the best time for Mars. That's when Mars really takes over the night sky and shows us what it's got. But what is Mars in opposition?
So technically, it is that moment in time when you have the sun, the Earth, and Mars precisely lined up so that at midnight on Earth, Mars is at its highest possible point in our terrestrial sky.
And if you were to look at it from space, what would they look from above? Like if you're looking down on the solar system and you're looking at Earth, Mars, and the sun, what would you see?
A line. They're just nicely in a line. And there's some years where, because Mars' orbit is a lot more elliptical than Earth's orbit, that we are noticeably closer. There's some years that we're noticeably farther apart. So back in 2003, there's a whole lot of hoopla because we were closer than
Right.
we'd been in hundreds of years or would be for another 100 some odd years.
Like 50,000, it was 50,000 years was the closest it had been, 2003.
And at these closest points, we are more than 20 million miles closer than we are during opposition when Mars is at its farther points. So there is a substantial difference.
Yeah.
But in the grand scheme of things, Mars is still smaller than allows you to see it as a disk without really good binoculars or a telescope.
But just to give people a sense of perspective, I mentioned this at the beginning of the show, it takes 2 light minutes to communicate with Mars, just over 2 light minutes right now, like when Mars is in opposition. And so you can, you send your beep boop commands to your rover, and your rover goes beep boop and sends back its commands, and it's just like you're playing a video game with fairly reasonable times. But when Mars is...
That's an old dial-up modem playing an internet
Yeah, exactly.
game.
But it gets worse, right? On average, the time to transmit to Mars is about 12 and a half minutes. And at the very worst, when Mars is on the opposite side of the sun, it's more than 20 minutes. So if you want to send some piece of information to Mars, you've got to wait 20 minutes for the message to get there and then 20 minutes to come back. So the distances are really significant.
And what's interesting is because it takes Mars 700 some odd days, Mars' year is 687 days to be precise, to go all the way around the sun. What we're looking at is every year the Earth has to go all the way around the sun. And because Mars is chugging along, we go all the way around the sun, and now Mars is over there, and we're trying to catch up, and we're trying to catch up. And we're only able to catch up every 2+ years.
Right.
And when we finally catch up, it's this grand observing time. But right before we finally catch up is the launch window to Mars, which is a very important thing.
Yeah. Right. So let's talk about the observing, and then we'll talk about the launch window. So,
okay.
If you've just with the unaided eye, without a telescope, Mars is super obvious in the sky.
And it appears quite red. And as we get closer and closer to it being in opposition, and this year the opposition is going to be on October 13th. And as we get closer and closer to opposition, it's going to actually appear towards the end of this month, September, to be brighter than Jupiter.
Wow. And
at that opposition, it is going to not only be brighter than Jupiter, but it's going to appear to be 22.6 arc seconds across, which is still really tiny.
Too small to see with your eyeballs.
But this is starting to be like the size of some of the craters we reasonably look at on the moon. It's 1/82nd the size of the moon at this point.
Right.
And the alignment in time is such that we have that Mars at opposition on October 6th, and on October 3rd, when Mars is basically as bright as it's going to get, basically as big as it's going to get, a couple of days don't make a huge difference. It's going to be 1.1 degrees away from the full moon. So there's going to be this fabulous moment where in a completely reasonable camera shot, you're going to be able to get the full moon and Mars right together, and trying to get the exposure times correct to get both well isn't going to be as hard as it usually is.
And then we're going to get all those people saying, how come I never noticed that bright red star beside the moon before? When, people don't understand that the moon moves, Mars is getting brighter and dimmer, that's not a star. It is the moon, though. You got the moon part right. But
There's a shocking number of people who don't realize that the moon isn't in the sky every night.
I know. And then the moon changes through its phases. Yeah,
Yeah.
people, I guess, just don't look up. Normally, when interesting things are happening and the full moon is out, the full moon rains on the parade with its light. But in this case, Mars will be bright enough that no problem. Full moon, use your telescope, look at the moon, look at Mars. They'll both look great. And Saturn and Jupiter will also be up in the sky at the same time.
Yes, and we saw those worlds go through their opposition during the summer. So this is really a great time to go out and observe planets. And given the observing conditions in most of the country, you can't see many stars. It's either cloudy for fall or smoky
moony.
because the west coast of North America is on fire.
Right.
But planets are going to be one of the few things capable of cutting through thin haze and thin smoke.
Yeah. The planets are so bright. Even in a city, if you've got any kind of telescope, now is your chance to see all of the best objects at their closest, brightest. Like really, like all the hits are going to be out in one night. Saturn, Jupiter, Mars at opposition, and the moon. This is the time. So let's talk about the launch windows then and why it's such a great time to send spacecraft to Mars.
Now, this really comes down to we like fuel efficiency in our rockets. Fuel weighs a lot. And so the easiest way to get to Mars is to use what's called a Holman transfer orbit. And this is an orbit where it's highly elliptical, and the shape of the orbit is such that the orbit's closest point to the sun is at the Earth. And when you're transferring to Mars, the furthest point from the sun is at Mars. And you need to launch when the alignment of Earth, Mars is such that you get to Mars orbit the same time Mars gets to that point in its orbit.
Right.
And you can do this for ideally, you want to be about 6 weeks before opposition when the Earth is still lagging behind Mars, waiting to catch up to Mars in the orbit. And there's a window, you change your velocity as needed, you change the shape of your orbit as needed, and that will get you to the right place at the right time. So right before opposition, we always see this grand lineup of spacecraft trying to make the window, trying to get themselves complete and launched and on their way to the world that is most likely to eat them instead of let them do science.
Right, because if they don't, how long do they have to wait?
They have to wait another 2+ years.
Right. So if you miss your deadline, you've got to like wait with your spacecraft. Keep your team going for another 2 years.
Yeah. So we're looking at the correct alignments occur roughly every 780 days. So it's a wait. It's a wait.
Yeah. So this batch, the 2020 Mars opposition batch, who went to the red planet?
So we saw Hope launching from an Arab nation. This was the first time that had occurred. We had Tianwen-1 and, of course, the Mars 2020 rover with its helicopter. And I've got to say, no mission has previously filled my inbox with the verve of the Mars 2020 system.
Have you gotten used to spelling its pet name, Perseverance?
I'm in the camp of calling it Percy.
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 So it's sever ants. That's how I do it. Sever ants. But sure, Percy. Yeah, fine. Call it Percy. Why not?
And if you're not following the Mars Percy Twitter account, it is delightful.
Now, is that the official one or like
No.
one of those hilarious, like,
Yes.
oh, okay, like the sarcastic Rover
Yeah.
Twitter feed?
It is truly delightful
Yep.
following the journey. And they're keeping up with the science fairly nicely.
So what do we know about these missions? I mean, it's great, right? Was it is it the UAE?
Yes, the
And
United Arab
yeah,
Emirates.
UAE and China, the Tianwen and the Perseverance from NASA. Three different, and there could have been a fourth, but somebody didn't make their deadline.
Yeah, that would be the Rosalind Franklin rover from the European Space Agency. They were working to land a heavy rover for the first time, and getting the parachutes right is really hard. And they did everything they could to try and hit their deadline, but they decided they would be better off and their spacecraft would have a better chance of survival if they just held back one more cycle and, well, tried again in 2023.
Yeah, we could see that one coming. They were
Yeah.
having a lot of trouble with that parachute system. It's a very similar parachute system to the one that Curiosity and Perseverance were using, and they were pretty sure that they had it all figured out, and then they were just having more and more trouble just making the whole system work. And they do these really great high atmospheric tests where they'll take the spacecraft up on a suborbital rocket, they'll release it at the right at
A
sort of at
model of the spacecraft.
Yes. Sorry, yes, a model. The parachute and a model of the spacecraft, and then
Yeah.
it will try to enter the atmosphere at the same density that Mars' atmosphere is when it will be doing entry, and then they have to make sure that the parachute will deploy all properly, and they couldn't pull it together, and NASA at the last minute actually assisted them, sent some engineers to help them try to get this all together. Let them use, I think they let them use a test facility to try and speed up some of the iterations. And in the end, they just couldn't get it to come together as quickly as they needed to for safety's sake, and
Yeah.
better to take a 2-year break.
And it's one of these things where it's a really hard call to make. I know that I remained heart pounding about including that helicopter, which was very much a last minute decision in terms of the timeline to build a spacecraft.
Yeah.
But the way that I'm trying to look at it is Percy is built on the same frame as Curiosity, the same basic infrastructure with updated instrumentation. So they weren't designing from the ground up, they were designing from the frame up. And so that gave them a little bit of a buffer zone to add in a helicopter at the last moment.
So let's talk about the purpose. Let's run through these missions then. So what is the purpose of, and I'm going to call it Perseverance. What is the purpose of this mission?
It's a sample collector, and it is out there literally starting to do essentially fossil hunting on Mars. They're collecting samples, they're starting to look for organic materials. And with Curiosity, they collect samples and then they poop them out because they only have so much space on board. And once they've completely processed a sample, it's out the door. With Perseverance, on the other hand, they're actually filling up canisters of samples in hopes that someday a second spacecraft will come and they're going to be able to take their canister and hand it off so that that canister can be brought back to Earth. Now, this is a high risk possibility. Spacecraft work with what are called landing ellipses, where we know fairly well where our spacecraft should end up on the surface of a world, but the landing ellipses are fairly large.
Mm-hmm.
And rovers don't move very fast. So it becomes an issue of, will we eventually be able to safely land a return vehicle close enough to Perseverance to collect the sample and then bring the sample safely back to Earth? So there's the landing close enough, there's the doing the handoff, and the returning all the way back to Earth are all high risk. But that is one of the ultimate goals. The helicopter is actually just a test of concept. It doesn't have a lot of science planned for it. They basically want to see, does this concept work? And it's not a quadcopter, people. It's an actual bona fide helicopter with that.
But it's got two rotors, right?
Yeah.
It's got
central rotor, balancing rotor, essentially.
right, and it's actually pretty big. Like it's not like a tiny little quadcopter. Like I think it's like I feel like it's like several feet across. Like it is a large vehicle.
You have to have a really big propeller when the atmosphere is that
Yeah.
thin. So the body, the basically propeller to mass ratio, is very different from what we have here on Earth, where we're used to propellers that are roughly the same length as our helicopters. Here, the propeller is substantially bigger than the body of the helicopter.
When does it? When will it get there?
I didn't write that number down. Do you happen to know that
I
number?
don't actually. Hold on.
Oh, Richard, we're sorry. We're sorry, Richard.
February 18th, 2021.
Okay, thank you. Okay, we will pretend I actually knew that.
Sure. Yeah.
Sorry, typing things into my screen so that I can have them on deck for when you ask next.
What, do you think I'm going to ask about the other missions?
Of course I do. So, with these missions, we're generally looking at about a six-month travel time. In this case, we're looking at Mars Perseverance will get there mid-February, February 18th.
Right.
In fact, we're going to have this whole flock of them all landing roughly the same time.
Or orbiting.
This is true. They aren't all landing
mission.
this time.
Yeah. So, and I mean, the thing I really love about Perseverance, I mean, you talked about the samples that it's going to be retrieving. I mean, NASA has been building this case for the search for life on Mars. They've been following the water. And with Spirit and Opportunity, was there ever water on Mars? The answer is yes. Curiosity, was there water on Mars for long periods of time? The answer is yes. Perseverance is, were there conditions that were good for life? The kinds of chemicals that you would want to have for life, maybe even the byproducts of life. This is the first mission that possibly will detect ancient life, the residue of ancient life on Mars. And it'll be the follow-up mission, the sample return that you talked about, that's going to be the one that actually brings these samples home and then the scientists get to crack them open and take a look at them. Is there some kind of noise in your background? I see. And cut this out, Richard. Is it an air conditioner come on? No. Is it somebody upstairs running his music?
No, it was Eddie barking at the mailman.
All right. All right, so we know what Perseverance is going to do, and the helicopter. The helicopter is, as you say, it's an experiment, right? Like they're not.
Yeah.
They're not going to depend on a ton of science. What will the helicopter do?
It will flit about. There will be a handful of attempts to flit. It's aiming to go tens to hundreds of meters. But this isn't going to be a way that they greatly increase the distance that the rover is able to travel. This isn't a way that they're going to scout ahead, although that would be cool. And it wouldn't surprise me if they decided to use it to scout ahead. As always with these tech checks, they don't make a lot of promises ahead of time. But then they often figure out, oh, this thing does actually work far better than we thought it would.
So the expectation is they're going to fly it a couple of times. They're going to crash it because that's what happens when you have a toy helicopter, right? You just crash it. It's inevitable. So
I don't know about you, but I've done that many times.
Many times. Yeah, are you kidding? That's like the first thing you do with a helicopter. I mean, is you crash it. A drone.
Or get it in your hair. That's another issue.
Yeah, or a tree or whatever, right? So there's no trees on Mars, there's no hair on Mars. So I like their chances of at least flying a couple of times. But it's got a little solar panel on it. It's got its own little battery. So once it takes off and gets to work, it'll just, as you say, be flitting around, ideally staying close to Perseverance, but not necessarily.
There's comms limitations, but
Right.
that's about it. It's
Yeah.
really kind of cute and cool.
But I mean, for as cute and cool as this is, a pack of lightweight flying helicopters like this for future missions or for even human explorers to fly around and provide some kind of external scouting will be incredibly valuable, because right now when you think about the rovers, they're just on the ground, they're looking around, they see what they can see from their perspective. They can't see that rock that's just over that hill. All they can see is what they can just see and what the satellite pictures will show them. So that's great. All right, let's talk about the UAA mission, Hope.
So Hope is going to follow in the footsteps of the TRACE mission that NASA has, and it's going to be working on studying the atmosphere of Mars, looking at atmospheric loss, and helping us understand what is the rate at which Mars loses an atmosphere so that we can better model what may once have been and better explain why you can't terraform Mars, people. You cannot terraform Mars. Stop
Oh,
asking.
I just heard 1,000 hearts break. Yeah. And what I also love about this mission is they launched on a Japanese rocket.
Yes.
You
And
know,
out of nowhere. Like,
well, I mean, Japan.
well, no, so I mean, in terms of like with Mars Perseverance, the amount of grand ceremony associated with this launch was truly a thing to behold. It was a spectator sport.
Yeah.
With Hope, like we knew when the launch window was, we knew there'd been some weather issues, and their window opened and they launched. No fanfare, just got it done. I think we had a few hours notice that the countdown clock was go. So the simplicity of it was deeply pleasing. It's let's just wait and see. Mars eats things. Don't do the ceremony and the this and that until it works.
Yeah. They, as I've mentioned in the past, Mars eats spacecraft for breakfast. And then the last one is the Tianwen, which is the Chinese orbiter and rover, and this is going to be very similar to the Chang'e 4 mission that's currently.
Yes, it's following in the footsteps of their exploration of the moon, where we've seen them putting in orbit communication satellites that are also imagers, which is a tradition we've long had, and then landing these rovers that use the orbiters to relay their communications back to Earth so that they don't need to consume as much power with their transmitters. They've mastered that.
Yep.
Being the first nation to explore the far side of the moon. And now they're taking their lessons learned and seeing how their luck fares at the red planet.
Now, they've got a bunch of regular old rovery stuff that's going on. It's, it does look similar to the one that's going to the moon, but the piece of technology that's on board that's very exciting is the ground penetrating radar.
And with ground penetrating radar, we can start to answer questions about, is there glaciation, is there frozen reservoirs of water underneath the surface? What is the density? We can use ground penetrating radar here on Earth to figure out what are the subsurface conditions of the tundra. Where is it soil? Where is it ice? It's one of the ways that we find old buildings buried in farmers' fields. We're not going to find that on Mars. But it is going to help us answer questions that InSight has really confused us with, because InSight was supposed to have this mole that buried itself under the ground, and it basically discovered that Mars ground just falls apart when you hammer on it. With the ground penetrating radar, we're going to start to be able to see what is the density, the structure of this soil as a function of depth, and start to understand, is this just layers of built up sand mixed with ice? Is there bedrock? Where is it? Is there ice?
Mm-hmm.
It's super exciting.
Yeah, the thing that we saw, I don't know if people remember, there was this study that came out from the Chinese Space Agency about 6 months ago, maybe, where they were talking about that the rover or the lander on the moon was able to see down into the regolith and see how deep the regolith goes, and how it turns into just larger and larger jumbles of rock until it turns into the bedrock, and it's quite deep. So imagine being able to drive around and see like how deep is the sand? Are there deposits of water? Are there even other interesting things? Salty, briny solutions underneath? Do they change with the seasons? So,
Yes.
with this mission, they're bringing a pretty exciting piece of technology to the surface of Mars. So it's a great addition to what's happening on Mars.
And I just like, I know this is probably never going to happen, but it would be amazing if they just happened to find gorgeous lava tubes that are beautifully empty right next
Right.
to all sorts of underground cool deposits that we can eventually imagine going and exploring. And the likelihood of something like that is like zero, but that
But
doesn't
to
make
see
it
one that's
actually
pristine,
zero.
like
Yes.
not with the roof cracked open.
Right.
Yeah,
Exactly.
yeah, that would be amazing. Good. So I think everyone, I hope you've got your preview for the Mars opposition. With your eyeballs, you're going to see Mars brighter and brighter and brighter, and then you're going to remind all your friends that that bright star beside the moon isn't a star; it's the planet Mars in opposition. And then you will watch over the next 6 months after that the coverage, and we get to go through the whole 7 minutes of terror again as Perseverance
Yes.
follows the fiery trail that Curiosity left entering
So
the
the
atmosphere of Mars.
So the dates to remember are October 3rd. We're going to have the moon and Mars a degree, 1.1 degrees apart. And on October 6th, if you want to drag people out and have a reason to look up, well, that's when Mars is at opposition and will be straight overhead at midnight, latitude dependent.
And then February 19th will be the landing for Perseverance. 18th?
Excellent. And we will bring it to
I'm sure
you
we'll bring it to
as
you
we
live.
can.
We did the last one. I'm sure we'll
We
do this one as
did.
well. Yeah. Right on. Well, Pamela, I'm looking forward to watching Mars Opposition 2020 with you and the rest of our fans over the next 6 months. So everybody enjoy, and we'll see you next week. Do you have some names for us?
I do. Thank you for the reminder, and thank you all for staying with us through the summer. You are the reason we're able to do everything that we do. So to our Patreons at patreon.com/astronomycast. Thank you to Harold Brandenhagen. Thank you to Daniel Losley. Thank you to Omar Del Riviero. Thank you to Marco Irasi. Thank you to Brian Kelby. Thank you to William Lauer. Thank you to John. Thank you to Dustin A. Roth. Thank you to Mark Stephen Rasnack. Thank you to Michelle Cullen. Thank you to Jeremy Kerwin. Thank you to Bruno Letts. Thank you to J. Alex Alexanderson. Thank you to Tim Garish. Thank you to Andrew Hamsworth. Thank you to Arzo Latz Hall. Thank you to Mark Grundy. And thank you to Iran Segev. Thank you all. You keep this show going.
And we'll see you all next week.
Bye,
Bye,
everyone.
everybody. And then they saved.
Yep.
577.
Yep.
Someone's asking if we know where the Chinese 2 sites in Utopia Planitia for the Zapfan's asking where Tianwen is going to land, and we've got 2 sites in Utopia Planitia have been suggested.
They're often still figuring these things out until a month before landing.
Yeah. Corey S. is asking, will the Chinese share their science? If the
They have been. They've
yeah,
been
if the
pretty good
Chang'e
about
mission
it.
is any indication, they'll share it in the same way that they share it with the Chang'e mission. So I would assume yes. In fact, with the Chang'e mission, they were really quite good, and like I have been following. I'm able to compare sort of how good a job does NASA versus Europe versus China, etc. And for the longest time, China was they were the worst for telling us anything about what was happening with their missions. You would get some news announcement on state media, and then we would all have to try to translate and figure out what was going on. And they've been doing a great job of releasing the results, releasing scientific papers in journals and things like that, and sharing pictures as they get them. So it's been great as a journalist, just trying to report on what they're working on. They haven't been making my job more difficult, which is always perplexing to me when people they like share information about our story, but I'm going to make it really hard for you. My answer is no. My answer is nah. I'm going to work on stuff that's maybe a little easier. So
looking over at the Twitch stream, I see there's news from Third Rock Astronomy that the Tri-Valley Stargazers Observatory is now gone.
Oh no. Where's that?
I believe it's West Coast. I just don't know exactly where on the West Coast.
Oh.
Pulling up the details. Livermore. So outside of San Francisco. The message coming out from Roland Albers, president of the Tri-Valley Stargazers, is our main observatory building was destroyed in the fire. The dome and the outhouses are still standing. At this time, we do not know if any equipment can be salvaged.
Oh.
Yeah.
What a nightmare.
So our hearts go out to them.
Yeah. Yeah. When we were watching, you shared a picture, I think. Was it the
Mount Wilson.
Mount Wilson, yeah, where you could see fire in the all sky cam.
Oh, that was not Lick. It's its sister observatory.
I thought it was Lick Observatory.
It is Lick.
Yeah.
Its sister observatory is Yerkes.
Yeah.
So both Lick and Mount Wilson. Mount Wilson is still threatened.
Yeah.
I looked at Mount Wilson's pictures earlier today and shared one where you just see this island in red haze surrounded by smoke.
Yeah.
You can't see anything of the surrounding mountains.
Yeah. A lot of our firefighters, because we've had such a reasonable fire season, a lot of our firefighters are down there. I've seen a lot of pictures of Canadian airplanes dumping water. We've got these gigantic water bombers that we use for fighting fires here in British Columbia. But that sucks.
Yeah.
Oh. Hit us with your questions if you've got questions. So James Dugan is asking, low surface gravity, less compact makes sense. Will this make lava tubes less stable? Do you think that lava tubes will be less stable on?
No, I'd actually expect them to be more stable because they have less gravity pushing on them.
But then they're also way bigger. They can form much bigger because they have less gravity pushing on them. Because we know that the ones on the moon are probably kilometers high, big enough to hide a city inside.
So what I don't know is the viscosity of Mars lava, because the viscosity of the lava is one of the other determining factors.
Right, that'll define how big the tube is. Yeah, but also there's like no earthquakes on Mars, so you don't have to worry about that kind of thing.
So it's lava tubes that are more recent are even better potential because the rate of asteroid strikes dropped towards the end of the volcanism era, like the age of the big volcanoes. And we've had continued volcanic activity until hundreds of millions of years ago, whereas the Great Heavy Bombardment ended 3.2 billion years ago.
Oh, speaking
so there's a period of volcanism that didn't have massive asteroid strikes.
Right. Okay. Speaking of Mars, I saw Away, which is the new Netflix series about the Mars mission with Hilary Swank.
How is that? I've heard really conflicting reviews.
It was fine. I enjoyed it.
Okay.
Yeah. I enjoyed my time watching the show. This is going to sound super weird, but I had a really hard time finding any technical mistakes
They got a lot of consultation from NASA.
They clearly did. You could see that they had, and so there was, the way they handled gravity, they clearly, somebody was thinking about, this is a zero gravity situation, and so they were strapping down, and they don't even, like, the whole episode is them flying in space, and so a lot of time was spent in zero gravity, and they had a lot of really great wire work was done. Some of the ways that the mission went made total sense. Some of their clever solutions to figuring things out made total sense. There was a few times where, like, I know why they set things up to make the plot go that way, and you're like, that's a dumb idea. They wouldn't have done that. But at no point did you just go like, that's just wrong. That's just demonstrably incorrect. Except for maybe communication times. They were communicating a little too quickly in the beginning, even though they were light seconds away from each other, and they were still just kind of chatting. But I'm going to give it a mild thumbs up as a very realistic space flight show on the same sort of level of realism, I think, as The Martian. I'm going to sort of put it at that level. More than, far more realistic than Gravity.
Good.
Yeah. But then, like, less interesting as a show. So it was, Carla was like, when are they just going to, like, do some spacey stuff? Because there's a lot of their relations back to home and Earth, and they miss people, and people are getting sick, and people are, so.
Have you watched Devs yet?
Oh, sure. Yeah. Yeah, I love Devs.
That one's super intriguing on the quantum mechanics side of things. That's all I can really say, because otherwise you give away the plot.
Yeah, no. It was. I highly recommend Devs. Watch it. Yeah. At the end of the first episode, if you're not just going, whoa, then that they will blow your mind on what that show is trying to do.
Another sci-fi one, but it's more of dystopian, is 3%. It's originally done, it's Brazilian Netflix original, so everything's subbed. Not subbed, everything's dubbed.
Right,
so
be
subbed. Prepared for voice and lips to not match. But it's another one that takes a really intriguing look at what could be. Yeah,
we watched the first season and then kind of stalled on the second season, so...
The third season really gets it.
Does it? Okay. All right.
Yeah.
I'll give it another crack. I'm sure I can pick it up from where I left off. It's not the first time I've sort of gotten halfway through a system.
It's now complete. There's nothing left to watch, and you can binge it all in a couple of days.
Yeah. Anybody have any questions? Nobody's got any questions for us?
It is a day of people rambling to each other.
People were asking how my Chinese progress is going.
Oh,
yeah. I just finished filling up a book of characters. If I can, is it around? Yeah, there it is. Hold on. I've got a book of Chinese character books. It's filled. I just filled the first book. So there's 22,000 characters in here. And this represents me knowing about 1,200 letters in Chinese. Essentially, it's sort of a weird idea, which is like, imagine if we took English and turned every syllable into a word, into a letter.
Yeah.
So if you say tomorrow, we say tomorrow. Imagine if that was three letters, tomorrow, and then anytime you use more, then you'd use that word. But there's roughly 3,000 of these letters that people in Chinese, in Mandarin and simplified Chinese use, and then there's the words on top of that. And so I know about, probably about 2,000 words in Chinese. So I can actually read. I can now read pretty much anything that I want to. I can read novels. I can read manga. I can read news is too tough, but I get about 75% of what I read. Listening is just terrible. I cannot understand anything that's being said. for me to be able to listen. I mean, a little bit. I get it when people say hello and things like that, but
Yeah,
it's definitely a journey.
one of the things that I've been debating is I noticed that Rosetta Stone is currently having their lifetime memberships at a drastically reduced cost.
Yeah.
So I've more than once subscribed to Rosetta Stone for a couple of months here, a couple of months there, just to get enough of a given language into my head that that country I was going to be in for a prolonged period, I'd be okay.
Yeah.
And I'm like, okay, this may be the thing I do. And I just, yeah, I don't know though.
Well,
I
if you
want to
wa-
get my Russian back to the point that
Yeah.
Russian speakers don't laugh at me.
That's cool. Yeah, I mean, you've already went to all that work to learn that language. It would suck to then just have it completely slip away from you. So,
It's not completely gone. It's just far enough gone that native speakers giggle when I speak Russian.
right. Yeah. So that's not that far to bring that back into some kind of ability. But
Yeah.
it's it's definitely fascinating, and it's mostly just a feat of endurance to get this stuff into my head. See, people are asking what's that? I don't even know the word astronomy. So I haven't. So right now I'm just trying to learn like basic daily life conversation type stuff, but I am also planning to very quickly specialize into learning the words for everything in having to do with space science.
Do you have a Weibo account yet?
A Weibo. I don't have a Weibo, but I do have a WeChat.
Okay.
Yeah. So anyway, it's but if anybody wants any advice in how to learn this or any other language, I definitely kind of feel like I've smashed myself against it long enough that I've got lots of good advice. Ryan Schmitz has a question. If you could travel the speed of light, would you get red shifted over large distances or crossing cosmic voids, or does that only affect light because it has no mass?
Well, you couldn't go the speed of light.
Let's say almost the speed of light.
If you're going almost the speed of light, light reflected off of you would be red shifted if you're going away from something and blue shifted if you're going towards something.
Right.
And the key is it's either light that your machinery is generating or light reflected off of you, your spacecraft.
Right.
We only generate light in the infrared, and yes, that would be red shifted or blue shifted. But if someone can see your infrared radiation, you're probably about to die.
Right. So you would be redshift. Okay. Nibbler asks, would Mars having no atmosphere at all make landing probes easier or harder?
Easier.
Way easier.
Yeah.
Yeah. Yep.
It would be just like landing on the moon with a little more gravity.
Yeah. Yes. That's the problem. The problem is it doesn't have enough atmosphere like Earth or Venus or Titan to make a nice landing with parachutes and make it really easy. And it doesn't have no atmosphere like Europa or an asteroid or the moon. It's got some atmosphere. It's got the worst amount. Some.
Yes.
So, all right. Well, I think we've reached the end of our hour. Man, it's so good to be back in the recording seat, and it was super fun to do a new show with you, Pamela.
And we have the coming weeks all planned out. We're going to start with isolated white dwarfs, how you get them, what they are next week.
Yep.
And then start a slow and steady voyage through the dead stars.
Yeah. Right on. All right. Well, we'll see you all next week. Thanks, everyone.
Bye.